Alright, in this video I am going to walk you through the process of putting together all of the toolpaths needed to actually make this little part, this little bracket in Fusion 360. So this is my example, and it should show you most of what you need in order to tackle the different levels of the training for this activity. So here we are in Fusion 360. We're in the design environment, which has the tools that you know and love for creating parts. But in order to work with the manufacturing tools, we're going to need to change from design to manufacture. Now, the entire panel of tools up here has changed, but I'm still looking at my part. One thing I want to verify before I go any further is that my units for this are in inches. If they're not, please change them to inches. And now I can start thinking about a setup. One of the things I noticed looking at this part is that whoever designed it did it in this orientation because that's how it was going to go onto the robot. But this is modeled with the z-axis up, and for machining purposes, we need to lay it down flat so that the z-axis is more extruding straight from this front surface. So that's part of creating a setup. That's the first step, is I've got to create my setup. And Fusion is creating what it thinks is my stock boundary all around this object, the material I'm going to cut it out of. But I need to make a couple of adjustments to this first. Let's walk through this little window and see what it has to tell us. The first thing I want to select is my machine. And I have the router coming in by default, but I'll show you how to do this in case it's not the case. If I select machine, Fusion's going to look for what machines are available. There's a whole library in Fusion 360 of different manufacturers, all the many different types of machines that it can just load in. The one that we use is not automatically on that list, but I've got it set up in a Team 20 cloud library. So you should be able to see under My Machines a cloud library. And here we have the ProLite mill and we have the Millwright router. Make sure that it says post Gerbil. So if I click that and select that as my machine, then that'll appear here, and that's a good first step. Next, I need to look at this stock boundary here. Right now, it is using the model orientation to define how this little origin point is arranged. And it has the z-axis up here towards the top of the screen. What I'd really like to do is to rearrange this part so that it's laying down flat, and I want to look at it this way. Now I want Z to be going up. So instead of using the model orientation, I'm going to select Z-axis and X-axis. So I want my Z to be going up and down. I'll pick any vertical edge on the part to establish the Z, and then I'll pick any horizontal edge on the part to establish my X. And now I can see that this origin has rearranged to do that, but it's flipped from what I'd like. So I'm going to flip the Z-axis, and I'm going to flip the X-axis, and now I have this arranged the way I want it to be on the machine. Z going up and down, Y going towards the back of the machine, X going towards the right side of the machine. And then finally, I need to place this stock point on the material. And this is an important step. Where I place this stock point is going to be the home reference point for all of my machining operations. Wherever I pick has got to match the home position that I set on the router in the other room. Most of the time I default to this lower left corner on the top of the stock. Sometimes I'll go to the middle, or sometimes I'll change that for special circumstances, but most of the time I default to that lower left-hand corner. So switching over to the stock itself, right now Fusion thinks that I want to thicken this stock, that I want to have some extra material all the way around. I don't. This is going to be cut out of one flat piece of aluminum that's this exact thickness that it was modeled, so I don't want to add any stock. I'm going to click no additional stock, and it's going to sort of shrink wrap the stock to my part and give me the exact right size material. That's all I need to do for this setup, so I'll click OK, and now I'm ready to start picking my toolpaths. This object is going to require two toolpaths. I have holes to make, and I have profiles to cut out. And I can do all of the holes in one toolpath. I can do all of the profiles in a second. And I definitely want to make sure I do my holes first. We don't want to separate the part from the material and then try and drill holes in it. That would be bad. There's a couple of different ways that we can make holes, And because I have holes of 2 different diameters on here, I'm not going to use the drill operation. The drill operation is what it sounds like. You're just drilling down through to make a hole, moving over and drilling the next hole. That works fine when the holes in your model are the exact same size as your cutting tool. If we are using a smaller cutting tool to cut out a larger size circle, then we can't do that with the drill operation. Drill operation would also mean we'd have to change cutting tools to go from the small diameter to the big one. So it's a good tool, but it's not what I want for this. Instead, I'm going to choose bore. Bore is going to make my hole by spiraling down through around the outside of the hole, and I'm able to use a small diameter tool to make a larger diameter hole. So if I click that bore tool, the options window for that pops up here, and I have more things to select. I've got to pick my tool first. Now, when I click Select Tool, again, Fusion 360 has a huge library filled with different tools with different characteristics, but the common ones that we use for Team 20 have been populated into the cloud library Team 20 tools, and you should see that there. So for this operation, I'm going to go with my default favorite tool here, the 3/16 diameter end mill with 1 cutting flute. It's tool number 5. And when I select that, I am given the option to choose some presets here. I normally go with this aluminum roughing preset, which I have my speeds and feeds dialed in for. So click select, and that tool comes in, and we get the little animation of the tool holder holding onto that tool. I'm going to verify here that my feeds and speeds are what I want them to be. I have 14,000 RPMs. That's what I want to see for the spindle speed, and that's not variable. Every spindle speed should read that. My feed rate for this is going to be 29 inches per minute. My ramp feed rate is what I'm interested for the bore, since we're going to be ramping down in a spiral. For that, I have it slowed down to 10 inches per minute, and that's the only feed rate that's really going to be a factor on this operation. So I'll switch over to geometry. This is where I tell it, what do I want to actually bore out? And here I'm going to select one of my holes, and to speed things up, I'll just check the box to select the same diameter, and now it grabbed all the holes of that size. And I want to make sure I get this hole too. So I'll go back to select the faces, and bam, there, I've got my last hole included. Now over to heights, and we'll check out our heights. Most of these I'm going to leave alone. My clearance height, my retract height, my top height is all fine. My bottom height I want to offset a little bit, because sometimes the cuts don't fully cut through the material, and that's kind of a pain in the neck. So I want to offset this by 20 thousandths of an inch, just to make sure that my cuts actually go below the part. If I look to the side now, I can see where my bores are extending that extra 20 thousandths of an inch down. And finally, I'm going to check passes. And sometimes on passes, on this little option here under passes, I have some changes to make. Probably not going to do anything with these, like creating a finishing pass that's going to come back and take a very small amount of material off. That's a handy thing to use. Or using multiple passes if I want to take a shallow depth cut and then come back and make that pass over and over again until I get through the part. For this bore, I don't need to fiddle with these. I'll click OK. It's going to generate those tool paths and show me a little preview. The other tool path that I need to make is the 2D contour that's going to cut around the outside and inside to make the rest of the shape. So from my 2D choices, there's 2D contour. My same tool is still selected here. That's good. I'm going to stick with that, and I'm going to stick with these settings. My feed rate, again, 29 inches per minute. My lead in and lead out is going to be the same. That's not very fast, so I'm going to stick with that. And now I can select my geometry. For the contours that I'm going to cut out, I'm going to go to the lower edge and pick the inside and the outside shapes. So 2 contours. Before I leave this window here, this tab, I'm going to check off tabs, because I don't want this thing to come loose and go flying out of the machine. So I'm going to secure it to the waist stock with a couple of tabs. The default width is fine, 3/16 of an inch. The tab height is also fine here. It's about half the height of the stock. And my tab distance is awfully close together. I don't need nearly this many tabs. So I'm going to back that off to about 4 inches, and so my interior piece is connected by 2 and my exterior piece is connected by 4, and that's good enough for me. So switching now to heights. Again, I'm going to offset the bottom height so that I'm sure I punch all the way through the part with this. And then to passes. Once again, I'm going to consider some things here. So I don't want to try to cut through this entire piece of material in one pass. That's going to be a little bit too deep for the cutter that I am using. So for that reason, I'm going to check multiple depths, and I'm going to make sure that my maximum step down here is 35 thousandths of an inch. I don't need to worry about finish cuts and things like that. I'm just going to make sure I'm not taking bigger bites than 35 thousandths at a time. So I'll click OK. I'll generate my tool paths. I can see that my tabs are working. They're showing up where they should. And now to verify that everything's going to work as predicted, I can come up here under Actions and hit Simulate. So I'm given this material here, and I can increase or decrease the speed, but I can play through the animation of all of these tool paths running. So here's what that looks like. Going through all of my bores, going through my profiles. Something to watch out for with the simulation. If the program detects any collisions between your tool and your workpiece, or your tool and your tool holder in the workpiece, or anything like that, those collisions will appear on this little timeline down here at the bottom of the screen as red lines. And sometimes those collisions are nothing, and sometimes they're a big deal. But anytime that you see little red lines appear down here, you've got to investigate and try to figure out why that's happening. Sometimes you have to tinker around a little bit with the order of your tool paths or some of your settings to try to get rid of some of those collisions. The other thing that you can see here is if we click over to the Statistics tab, you can see what your predicted machining time is, and this has been pretty accurate. You can also see how many operations ran and how many tool changes were involved. Only one tool on this entire part. So this is a good way for you to verify the accuracy of your work. You can compare this against the times that are shown in the instruction slide and see if you have all of your feed rates and operations set up the right way. If you're off by a little bit, see if you can figure out why that is. The last step after you have created working tool paths and you've had a mentor look things over and give you the thumbs up that yes, this part is good, it's ready to be machined, we have to post the G code. And for that, we're going to click here again under Actions, and we're going to find Post Process. And this is going to take all these neat little toolpaths you've created and turn them into lines of G code that the CNC router can actually read and follow to make this part. So we've got to make sure a couple of things are set up correctly here. Under Post Process, we're going to make sure we have our machine, and we're going to make sure we have the correct post. The post is going to be gerbil. If it doesn't come in automatically, you've got to click on the folder and find it from the list. There's a couple of other gerbils in the mix, but we don't want to pull one of the other ones for, say, turning. We want to make sure we have this one. We need to give the program a name, and we have sort of a convention that we use for this. Normally our parts have got a part name and number, and we like to use those same part names and numbers. So this part might be called ARM 21. That's how we can easily find it in the folder. And then we give it an underscore and enter the size of the tool, in this case 0.1875 end mill. And then we give the size of the material, in this case 1/16 inch aluminum. So now if I find a big long list of project files, G-code files in the folder, I can tell exactly which one is this part and which tool I need to have in the machine for that and what material I need to have mounted to the machine for that. Just makes the machinist's life a little bit easier. For the output folder, we're going to browse through the choices. We're going to find in the student shared drive under the directory high school, tech, Dillman, and Team 20 NC codes. That's the folder where we want to push this thing, so select that folder. The units on this, they're going to be the document unit, which if you recall from the beginning, we set to inches. That's an important step. We want to make sure we're not designing something in inches and exporting it in millimeters or something like that. The last thing to double check here, Two more things. We want to click on the operations tab and just make sure that we have both of the operations that use this tool, and make sure that we never have operations listed in the same G-code file that have multiple different tools. If there's a tool change, we have to run those as separate files. We do not have an automatic tool changer. And finally, looking at this option right here, safe retracts and home positioning. By default, it probably comes in looking like this, G28. We do not want to put a G28 in there. That's going to cause problems immediately when we start the file. So we're going to switch that to clearance height, and then we can click post. Stay tuned for the little success message in the bottom corner, and then communicate with the machinist to let them know that this file is ready to rock and roll.